All right, and this question wants us to verify that pi over 3 is a solution to this equation, and then part B, verify that 4 pi over 3 is a solution. Okay, so that's just the main thing. We don't have to solve this. You can pretend like you've already solved it. You got these two answers, and you're just checking them. It's important to check your answers because sometimes you're going to have extraneous answers. Even if everything you did before that was algebraically correct. And it's just a good idea to check your answers because it helps you check for careless mistakes. So that's what we're going to do here in question 5 before we get into actually solving some ourselves. All right, so if I plugged it in for part A, tangent pi over 3 minus the square root of 3 equals 0. Okay, and then we need to think about on the unit circle, 1 pi over 3 is right there. And I have those tangent values memorized, so I know that that's square root of 3. If you have not memorized those tangent values, then you need to think about sine and cosine at that point and do sine divided by cosine to figure out that it's the square root of 3. So of course this is true. So it looks like pi over 3 is a solution. Try the same thing with 4 pi over 3. Just plug it into the original equation and see if it works. So this time we need to be evaluating tangent of 4 pi over 3. So that would be 1 pi over 3, 2 pi over 3, 3 pi over 3. Here's 4 pi over 3. And again, I memorized the tangent values because there's only a few of them, and it's just super helpful. That ends up being square root of 3. In this quadrant, sine and cosine are negative, so negative divided by negative becomes positive. Also tangent is positive here. I almost said negative, but square root of 3 minus the square root of 3, of course, is 0. So it looks like 4 pi over 3 is also a solution.